Раз, раз. Hello, friends, and I'm presenting you Jan Eyberg. He was talking about the climbing out from the digital mud with unikernels. Thank you.
All right. Yeah, so thank you. My name's Ian Eyberg. I'm the CEO of DeferPanic. We've been building out unikernels for various companies for the past couple years, and this kind of, if I know how to use this clicker, will kind of give you a demonstration of what we've been up to the past couple of years and what you might look forward to in the future. So for the past 4 decades, we've been living under this monolithic operating system paradigm. You know, so Linux and even Windows, to that matter, that we're all familiar with, it has the same sort of basic operating system design that Ken Thompson and Dennis Ritchie were working on 40 plus years ago. And it worked well back then, but today's 2017, almost 2018, and it's a little bit different in our cloud environment. And we just have layer upon layer upon layer of this digital mud that has been coalescing up. You know, we have things like the BIOS, right? So what good is this in our cloud environments? Most of us probably don't touch physical servers today, yet our operating systems still have to deal with this. Why? Because they're not meant to be living in the virtual world. And then a couple of years ago, there's a paper that came out called A Decade of Wasted Cores. And basically, the whole paper's premise was, you know, the scheduler in Linux was a complete waste for the past decade, and it really was not doing a great job of balancing program decor. And when you start thinking about these things, you start thinking, well, what is this monolithic operating system design actually doing for us? And to go even deeper, you know, to give you an idea of like how bad things really are, libxml2. This is a library that's compiled into pretty much every single interpreted language out there. PHP, Ruby, Python, whatever, and most of the compiled languages as well. Chances are this is on your system right now. And this are 2 free after use vulnerabilities discovered not just a month ago. And if you can tell, this is nano FTP. What is an FTP server doing in this library that's present on every single system out there and has vulnerabilities from less than a month ago? This is the type of digital mud that I'm talking about. This does not belong on our systems all the time. Then we have things like USB drivers. So in today's cloud, do you have access to a USB disk? I mean, yes, I have one for this laptop, but not on my server. My server's a virtual server, and it doesn't have the concept of an audio driver or graphics for that matter. So why do we have them on our servers? It makes no sense. And then you have jokes like this, Docker, which is basically the MongoDB of DevOps, and that's kind of throwing a little slight there. So let's talk about the history of software development for the past 4 decades. You know, I mentioned 1960, 1970, we've been living under this paradigm. So it really goes back to January 1st, 1970. This is, of course, the Unix epoch, right? And so Ken Thompson and Dennis Ritchie, they're working on a PDP-11. When this machine came out, it cost over $500,000 to produce. It had to support multiple users. It had to support multiple operating systems. Look at the size of this machine. It took up a whole freaking room. And so there was no way that they could make an operating system that was only for 1 program or for 0 users. The problem is that we're still using the exact same sort of design concepts that they were using in the 1970s. We fast forward a decade, and you know, IBM and other companies like that really push this concept of the personal computer. And so now, you know, small business owners and small families could afford their own personal computers. And so now you could say that it was maybe a single user system, but it still had many other programs that you were using. Maybe it was accounting software, maybe it was text editing, whatever. And so our paradigm of this multiple user, multiple process system carries on into the 80s. And then we go into the 90s. And so the 90s was, of course, a really special moment for most of us, right? We had the birth of the internet, and companies en masse started taking on more and more compute power. And so the 90s were also special because it was really the end of these monolithic servers. This was the very tail end where we could point at and we'd be like, this is the database server, this is the web server, this is the whatever server, this is Zeus, this is, Mars, this is some other Roman god. And then we come into the 2000s. So 2000s, we had companies like VMware and Citrix come out, and they really pushed virtualization everywhere. They did such a really good job like this that a few years later, this guy, Jeff Bezos of Amazon, created this thing called EC2, and this forever changed the way that software developers push code out to production. Now developers were not touching servers at all. They were clicking a button and spinning up hundreds or thousands of servers on demand. And so this was a dramatic shift because now we have the capability to do what I'm going to tell you in this talk. So let's get back to the basics. What exactly is an operating system anyways? This guy on the left, if you've ever taken an operating systems course in school, you're probably using his textbook. This is Andrew Tannenbaum. He got in an infinite Usenet flame war with Linus Torvalds back in like 93, 94. Core argument was like, microkernels versus monolithic kernels. Linus ostensibly won, but maybe not because of technical merit. After all, this guy was teaching operating system design. But let's go to the other question. What exactly is an application, right? Well, at the end of the day, if you're on Linux, this is an application right here. This is the magic header for an ELF binary. And so when you think about what an application needs to do when it runs on something like this laptop versus on your server, it's completely different. On the server, you don't need much. You need to talk to the network and you need to talk to the disk, and that's about it. And so you don't really need a lot in your application, and you don't want a lot. And then we have security. So I don't know who in the audience would actually recognize this picture, but this was taken about 15 to 20 years ago in DEF CON in Las Vegas. It's a notorious hacker convention. And this is the Gobble security crew back then. So this is like 01, 02, something like that. And so the guy on the right is the Unix terrorist, and this guy's Gobbles. And they kind of caused hell from like 98 to 02, around those years. The Unix terrorist guy, he actually wound up in jail because he was one of the guys behind the Target credit card stuff. So anyways, what I'm getting at is this was 15 years ago, and you can still hack servers the exact same way that these guys were 15 to 20 years ago. Nothing has changed whatsoever. And it's not just the bad guys, right? It's benign stuff. This is a true story. It didn't happen to me, it happened to a friend. But this guy was an ops guy, and he got a call from PagerDuty. Some server was blowing up. So he pops onto it, and he sees a bunch of this nonsense, fork retry, resource unavailable. So he's like, my limits are off, right? And so he pops onto the server. He says, you know what, I'm root. I can do whatever the hell I want. And he discovers that as soon as he tries to edit this file and change the limits, his text editor, Emacs, was not installed. I'm a VI guy, but he was an Emacs guy, so he sudo apt-get installs Emacs. Remember, he's just trying to fix this problem so he can go back to sleep. And he takes his victory beer, right? He thinks he's done. 2 weeks later, he finds out that he got heartbleed. And so just by that sudo apt-get install Emacs, when he was trying to fix another problem, he actually made another problem in the process. And so security cannot just be like the bad guys, but it's also like our own people. So sudo fucking shit, right? But and then we run into things like this. So this made really big news over in the US a couple months ago, still making news. Equifax is a company that collects personal credit information on every single American, and they got totally hacked to death just a couple months ago. Over about half the US population's financial records were leaked out. The CIO, the CISO, the CEO were all retired, but in their game, when they get retired, they are done. They will never ever hold the CISO job title ever again. They will never hold the CIO job title ever again. when they got fired for life. You know, Federal Trade Commission, this is a government agency that ostensibly looks after consumers. They're looking into this. There's multiple congressional hearings, so if you're an American business person, that's the last thing you want to do is go testify in front of the government about why your servers were not secure. There's insider trader investigating. So basically, a lot of execs sold their shares of Equifax before they broke the news, which is a big no-no. And that's kind of like go to jail time for them. So that was really bad. And of course, there's just like dozens of class action lawsuits. Literally over half the American population's financial records were out in the open because of this. So this was a huge, huge deal. And it came back to Apache struts vulnerability, right? So I'm not picking on Apache struts, right? Everybody out there has their own problems. But just to highlight how bad this particular problem was, and it's kind of hard to read, but this is a curl request, right? And so this little proof of concept, all it does is look at the operating system. If it's running Windows, it pops command-exe. If it's running Linux, it pops a bash shell. In one request, they can remotely execute code on the other guy's machine. That's how dead simple this thing was. And my question to you is, like, you know, there's an elephant in the room here, right? There's an elephant in the room, and that elephant is you should not be able to run your code on somebody else's server. That just should not be a thing in 2017 anymore. And we think about like exploits and attacking servers and like what can my exploit do? Well, I can steal passwords, or maybe I can pop a shell, or maybe I can connect to that database and steal all this information. However, what if you had a system where you could not do any of these things? What if that was just not an option? So I'm postulating that the future here is unikernels. At least from a security perspective, unikernels prevent all of this because they prevent remote code execution by default. So a brief overview of unikernels. They're single process systems. They run one process, one program per virtual machine. So this computer is running hundreds of programs at a time. My server right now is running hundreds of programs. You boot up Ubuntu, it's immediately running like 100 programs all at once and 20 some odd users. Unikernels have one process. You quite literally cannot get a shell on a unikernel. So that exploit back there simply does not work anymore. There are no users. There's no concept of a user. You can't really do anything. There is no shell to log into. There is no rights management. It's just one process running in that isolated space. And so we throw that security model out the window. And as I mentioned, there's no shell. So this is pretty big from a security perspective, because when you think about attacking a system, this is the very first thing that you want when you're attacking a system is a shell, because once you get a shell, you can sudo apt-get install whatever you need, or you can do that loop back to yours. You know, without having this, you have to bring along all of your code and all of your libraries and everything that you need to further your attack. Even if you're going to, say, dump a database, now you got to bring that SQL library with you. Now you got to bring a way to talk back. You know, all this needs to be coded in, and that makes exploiting these systems dramatically way more difficult. The attack surface is ridiculously less. Instead of tens of millions of lines of code that you might find in a comparable Ubuntu system, for instance, unikernels can have tens of thousands of lines of code or less. They're very, very, very small. Way less libraries, way less files. I'll show you later what a file system looks like for it. Now, what are some like real-world use cases for unikernels? Well, just from people that we've engaged with in the past so many months, we had an example where this oil platform, they had 20+ rigs off the coast of the Gulf, and they wanted to secure control data that was coming back mainland. And so this is like data that's analyzing their pumps. And so forget like trying to secure the controls to the pump itself. That's That's obviously something you want, but they're just talking about the data because they do a lot of data processing and they want to move it back in a secure way and not have like one of their competitors steal their data. And so security was first and foremost on their mind. Another one, a biotech firm wanted cheap, secure compute, so they have a massive footprint. And in the US, biotech firms are heavily regulated, so they can't use cloud services like Amazon and so forth. They have to build up their own infrastructure on-premise. And this is pretty expensive and costly to do. Takes a large ops team, that sort of thing. And so they were looking at unikernels from that perspective. Now, some notable unikernel projects before I show you the others that are new. Solo 5 and Micro KVM are two projects from IBM Dan Williams is working on. And Micro KVM is a new unikernel type of monitor that basically you can run unikernels with QEMU and KVM, ESX, all this stuff. But Micro KVM is a new monitor that allows you to run them specifically for unikernels. And so that's one interesting project that's going on right now. Another one that's less than 1 month old is called Unicore. And so this is out of NEC. And I don't know if any of you have ever looked at or had the pleasure of hacking around with the MiniOS source code in the Zen project, but it's a mess. And NEC recognized this, and they've been working with unikernels for 3 or 4 years now. And so they wanted to completely rethink that project. And so this is a brand new Zen project that's being worked on right now. And then another very new project in the space is LightVM. And so LightVM is also out of NEC. And this was actually just presented at a conference maybe 2 weeks ago. But basically, Florian, who is the main project lead on this, he was booting unikernels in about 2.3 milliseconds, which is just slightly slower than a fork system call. And it's about 2 orders of magnitude faster than spawning a Docker container. So ridiculously fast. And he was booting 10,000 unikernels per server, and crappy server, I should say. It was not like a good server at all or anything. So I was going to do a demo, and I'm not sure. We got a little bit of time. So if you guys have your laptops, another way that you can kind of experience unikernels on your own laptop, go to github.com/deferpanic/Virgo, and you can download this. This will allow you to kind of boot up unikernels and run them. And we can kind of show some quick examples real quick. Allows you to search for existing apps, create new apps, show running apps, show installed apps. This allows you to do it all locally on your own computer. So, you know, if you wanted to search, you could say Virgo search, you know, whatever string, and you can pull up a list of your projects, different languages, and different repositories. You could start a new project. So in this example, we start a new PHP project. You just point at a GitHub repository, and it starts creating a unikernel on demand. And then you can download that and play with it. It's a little bit more API. Man, I wish I had. But anyways, to run the unikernel, it would be simply Virgo space run / whatever the project name, DeferPanic Go, and then it'll go ahead and boot it up. Runs on Linux and OS X, no Windows, sorry. Those are the two supported systems right now. And, you know, basically the same thing. So my question is to you, like, unikernels, in my opinion, are the future from a security perspective. There's lots of other things that we didn't even touch on, like resource consolidation and so forth. But from just a security perspective, we kind of see unikernels as the future. So love to take any questions you all might have.
Hello, and sorry for my English. I just don't get in what exactly way the unikernels are different from Docker. Because, you know, there is a lot of stuff around Docker. You can compose, you can build it from scratch, you can do everything. And like, there are thousands of tools and orchestration stuff around it. And is the unikernel like way of building applications itself, not the isolation tool? So I just didn't get it.
Yeah. So yeah, great question. So they're completely apples and oranges. They're two completely different technologies. Unikernels, at the end of the day, usually output a virtual machine. So a very small, secure, lightweight, 10 megabyte, 20 megabyte virtual machine. Whereas a container is going to output a container, and it needs to be running under Linux. So the unikernel virtual machine does not have Linux as this kind of host that it's running under. It's all contained by itself. There is no, it is the operating system. It's the application and the operating system combined into one. And so if you want to run 2 or 3 or 4 different unikernels, they're all going to be separate virtual machines. And so, but you can package and compose your application in the same sort of manner as Docker would, but with true isolation. So Docker does not give you actual secure isolation. It's very easy to break out of containers. There's tons of exploits out there for them. Whereas breaking out of the virtualization layer, that's much harder to do. And if you have an exploit for that, right now we're all screwed. So.
How do you debug unikernels?
Yeah, so there's plenty of ways. You know, personally, I just use whatever tools exist. So I use Go, and so I debug the way a random gopher would debug. You know, you can use GDB. You can use many other different debuggers out there. At the end of the day, unikernels, you don't necessarily have to debug the end VM. But even if you do want to, it's easy enough to attach to, you know, if you spawn it up under KVM or something like that.
Thank you for your talk. I have a question regarding running unikernels. How do you run them in production when you are not on your laptop? How do you run them on an actual server?
Sure. Yeah, so at the end of the day, they are virtual machines usually. You can push it out to bare metal, but you lose a lot of the advantages by doing so. And so you would spin it up under like a KVM or ESX or something like that. You can deploy them to EC2. You can deploy them to Google Cloud and other big cloud providers, but they lose some of their advantages. So they're best in more of a private on-prem environment today. Maybe in the future, that might not be the case. So.
Hello, great talk, by the way. I like it very much. I have one question, and it is, what are the core syscalls that the unikernel provides to the application that is running inside this kernel?
Sure. Yeah. Good.
I mean, what are the? You said that it gives you access to the storage and the network.
Yep.
Is that everything?
Yeah. Yeah. So good question. I guess it's a couple different questions. One is that there's no unikernel standard right now. There's 6, 7 big projects out there. Some of them don't really give you access to many of the system calls at all, and they're very obscured. And then others, like the rump kernel project or something like that, you have access to basically most of what is POSIX with a lot of exceptions, right? So one right off the bat is fork. Like fork will not work on pretty much any unikernel implementation out there. Why? Because it's a single process system by design. So under rump kernel, it's just stubbed out. You call it and you'll get like this little printf message saying it's stubbed out. But you can also think like shared memory, anything that deals with shared memory, anything that does IPC against different processes, none of that stuff's going to work in unikernel land. So if you want to do the equivalent of IPC, you do what we're all doing today anyways, and it's all across the network, which we're used to. So
what is the overhead, actually? If you want to run a process inside
Yep.
a unikernel, I guess there are different unikernels
Yep.
that are running that you can use to run your application. But the one that you are using, how much overhead does that in terms of CPU and memory
So,
on top of the
yeah, great question. Great question. So at the end of the day, you are paying the virtualization tax, but I would say the vast majority of us in this room are already paying that tax because we're probably in a virtualized environment. So if apples to apples at that point, there is no tax. What's really cool from the Iюнь kernel perspective is the lack of a lot of these system calls leads to less context switching. And so that's context switching between the process to kernel and also from process to process. And so every single context switch, we're not interrupting the VM every single time when that happens. And so we save a lot, ridiculous a lot. You know, if you look at the OSV guys and their project, they're showing things like Cassandra, Memcache with 200x speed up. So you can actually achieve better latencies and faster boot times and many other speed advantages simply by using Iюнь kernels. There's some guys that are booting these things in 10 milliseconds. I mean, like that one guy I showed, 2.3 milliseconds. So in some cases, they can be ridiculously faster. Yeah.
Hello, thank you for a great talk. I want to clarify a moment about single process.
Sure.
Does it mean that I cannot run something like an Nginx or other applications that require multiple processes?
Yeah. So great question. I'll give you an example right now. Postgres. So Postgres by definition is like the System 5 IPC stepchild, right? It does everything in that space. It does the semaphores. It does the process sharing. It does you know, IPC. It does all these different processes. Postgres, you would have to work very hard to stuff into a Iюnь kernel. I actually did this as an exercise about a year ago, and I was like, man, this is kind of a pain in the ass. Every single fork call you want to transfer to a thread, you have to figure out what to do with shared memory, all this sort of stuff. But what's great is if you look at most modern web applications, this is not the case. That style of programming was really dominant in the late 90s, and it's not today. Today, a lot of people, it's, you know, this process on this core, and if you want to communicate, you go across the network. And so since we have that new style of development, it's not that big of a problem anymore.
You're talking about 11 binaries in your talk.
Sure.
And as I understand, when you start using Iюнь kernels, you should remove file system at all. So you don't need file system. And the way how program is loading also changes. And is it true today, or we just go into this way?
Yeah, I mean, I would love to show you some demos. I could do this after the talk, but no, they're very much are file systems. You know, I have demos where I show, you know, editing the files on the file system and stuff. But yeah, I mean, like at the end of the day, most applications need to have some sort of state of some kind. And if we're talking like databases, obviously you got to mutate that state. So file systems definitely exist. And they look just like any other file system. And it doesn't matter if it's ext2, ext4, Btrfs,
but
whatever.
You really don't need file system. You just need to start your binary and to talk by network. So as a layer, a file system is very difficult, and you also can remove it. Yes.
So yeah, to answer your question, there are definitely people doing that without that layer of complexity for sure. There's kind of like two breeds of Iюnь kernels out there. One is kind of like the very pure, we don't need anything type of Iюnь kernel, and then there's the other of like, hey, I want to run legacy applications as Iюnь kernels, which we say those are like the POSIX, you know, standards, which is bullshit, but that's how we segregate them. So yeah, in your example, like some of the OCaml ones, they have many examples where they don't use file systems, and it's just like them talking to the network or something like that. So yeah.
What's your unikernel of choice?
I mean, so we've done a lot of work with the rump kernel project. Rump kernel. So Dr. Antti Canty spent better part of a decade working on how do I debug. Basically, his thesis was how do I debug kernel drivers without having to restart the damn system every single time. And so his work led him into having this idea of a rump kernel, which was just an easy method of stubbing out different kernel features. And then, 5-6 years ago, the idea was like, hey, by the way, we can just repurpose this as a unikernel application too. And so now we can take our application, cross-compile it down into this VM and run it. And so, we made the first Go unikernel actually 2 years ago, right after I gave a talk over at HighLoad the first time. We booted Go up on KVM, and that was using rump kernel as kind of that project get off. So a very new one's called TinyX. This was once again just announced like 2 weeks ago out of NEC, and so that's definitely something that I would pay attention to. And also Unicore is also which is now an official Zen sub project. So.
Any more questions? Okay. I have a question for you. I have a question for you. So it's a new paradigm to how you develop your application.
Yep.
So will it lead to the problem when we are supporting VMs, Docker, and unikernels in one system?
Yeah. So I would say we already have that problem, even without unikernels or even without Docker for that matter. It's I spent the first half of the talk talking about like how much complexity we have in our systems right now, and like I could put like dollar amounts to how big of a problem this really is, having this kind of monolithic operating system, even though today, even as developers, we're already segregating our apps, right? We're like, oh, these are the app servers, these are the database servers, these are the whatever servers. And so we're already segregating them by function. And, honestly, like most people, like there's a mutable infrastructure talk right after this, for instance. And, a lot of developers are already saying, hey, we manage hundreds or thousands of these VMs. There's no way in hell you're going to manage that manually anymore. That's just crazy. And so all these different, developer workflows that have been emerging in the past 5 years have been kind of pushing us down this road towards this, what we think is kind of the logical conclusion. And so we're about removing complexity, not adding it.
Thank you for the talk. Could you please elaborate a little bit more on the real-life example you've provided about the oil company? Do they run this unikernel on their bare metal or how? Yeah, so great question. So unikernels have found applications in lots of different ways. We're primarily looking at it from kind of a cloud/data center perspective, but there's a lot of IoT projects and there's a lot of NFV projects out there. So I know the team over at Ericsson that's been working on it for network functions. They're looking at it from like latency things because they need to spin up these network functions and spin them back down in like milliseconds, and they want to do it hundreds or thousands of times. Some people were looking at from like edge firewall use cases. For the oil company example, they actually have a system on a chip, set of computers that reads off control data, and it's like tens of gigabytes, every hour or whatever. Because it's all this sensor data. They don't scrub any of it. They take all of it and then they ship it off. And they it's very sensitive to them. They don't want anybody looking at it. They were actually using Rust to, as their language of choice, and then they cross-compiled that into a unikernel. And so it's an ARM system on a chip for that application. So and on that note, there's a lot of interesting things coming down the pipeline. The ARM v8 chips, and
kind of the support that they're starting to get virtualization-wise. Because at the end of the day, yes, you could deploy straight to the chip, but you probably want to keep that in an enclave of some sort. And so that's some interesting stuff coming down there.
Thank you for your speech. Just want to ask, is there much difference, I mean, in terms of API, like how you can manage containers and you can manage VM? I mean, I think VM can work with Docker and unicorns. Why not? Is there any like works in this direction or something like this?
Like an orchestration system?
Like orchestration, or even like you can write Docker file for you write Docker file for unicorn, for example? Because like you can run bash, because like why not? Because unicorn is eligible to run only one process. You can run bash and then like run another process and something else. Why not? I mean.
Yeah, so it's a little bit of a deep dive question, but at the end of the day, it comes down to the type of unikernel you're creating. So at the end of the day, it's a compiled language or it's an interpreted language. Compiled language, you're going to have, every time you hit that deploy button, you're literally going to recompile that image. This is also kind of a cool security feature, in my opinion, because that image changes every single time, versus like EC2, you get that exact same image with the exact same memory address, and as an attacker, I know that. So that's one thing, but if you're using an interpreted language, this is where orchestration, development, and deployment can be a little bit different, because say you're using Ruby or PHP or something like that, if you've compiled in all the native dependencies, as we call them, you know, beforehand, there's no reason why you have to keep compiling that image because it's already compiled. Maybe you just have to mount a new file system. And so this is some of the deployment patterns that we've started to find that work well, because, you know, if it's just an interpreter that you compiled down, you know, the PHP or the JavaScript or whatever, you know, that's just a flat file that maybe it's a 20K file system that you change out as part of your deploy process. And so there's really interesting things that you can kind of do when you start like realizing it. Now at the end of the day, being a VM, we get to use all of the VM goodness that we've had for 10 or 15 years, and we don't have to screw around with the Docker ecosystem. So it's a lot more mature in that regards, in my opinion. Orchestration-wise, though, you know, the virtualization environments that we're used to dealing with are expecting maybe 10 VMs a server, or they're only expecting you to manage 100 or whatever VMs. Well, unikernels, you know, we'll spin up like 1,000 VMs and spin them back down in a matter of seconds on shitty hardware in our own data center. And so there's lots of interesting things you can do when you realize that you can spin stuff up and spin them back down in a couple milliseconds. And lots of them at the same time. So there's room for newer orchestration software, is what I would say.
Is this already supported by background?
Yeah, I mean, we're one of them. So,
it works,
yeah.
I noticed you didn't mention Java in your last answer. Can we run Java in unikernels now?
Yes. Yes, there's lots of Java applications out there. In fact, OSV, one of the first companies out there, was OSV? Java was like, yeah, that was like one of the first things that they were working on. So OSV actually has some like real luminaries working with them, like Dorlor and a couple other guys. So that was the exact same team that wrote KVM. So they were supporting like Cassandra, for instance, you know, running 20 times faster as a unikernel versus on some comparable VM, same kind.
Thank you.
Can I ask some question about the future? What do you think? If we do we have any standard emerging for unikernels, like Open Container Initiative we have for containers and images? And do you think we will have this for unikernels?
Yeah,
sometime?
so I don't know if there's going to be a standard because there's so many different applications that people are using. You know, I spoke about the IoT, and then I spoke about the NFV, and then, you know, there's like web applications, which is what we're interested in. Those are three completely different domains. Like, whatever kind of software you would build for the network functions is going to look completely different than, say, like a, you know, a web application type of setup. Having said that, I do think the libraries and the tooling and the orchestration, all of that stuff will definitely improve, and definitely, you know, there'll be much more software out there for that, for sure. Standards, I think that's not really going to happen. So.
How much time do you need for demo?
I mean, I could show you something in 5 minutes if we got that. It's just really about looking it up.
Can you show?
Yeah, yeah. Try to do this real quick. All right. I just steal. Actually, I got something in my backpack here. Suppose you got a VGA to HDMI or anything, do you? I thought I had one, but. Yeah. Shit. Yeah, I think it's. Huh. Yeah, I'm not sure. Do you have a adapter? That's fine.
Thank you very much. Let's applause.
Cool. Yeah.
And we have a 10-minute break, 15-minute break. We'll start in 12.